On the night of October 3, 2025, a thin, bright streak appeared in the Martian sky, just as the interstellar visitor 3I Atlas was sweeping past Mars. The image came from Perseverance's navigation camera. It looked clean, straight, and strangely perfect, exactly the kind of frame that lights up the internet. Some people said it proved everything from alien craft to secret probes. The more boring answer is also the more useful one. When a fast object crosses a camera's field during a long enough exposure, it turns into a line. That doesn't make it boring, it makes it measurable. Here's the story behind that streak, what Mars likely saw, and why this quick pass by a distant comet may give us better data than months of Earth-only observing. First, 3I Atlas is only the third confirmed interstellar object ever found, after Oumuamua in 2017 and comet Borisov in 2019. It was discovered on July 1, 2025, by the Atlas survey in Chile. The giveaway was its orbit. Not an ellipse bound to the sun, but a hyperbola on a one-time pass through the neighborhood. Unlike Oumuamua, which sparked endless debate because it didn't look like a normal comet, Atlas has behaved more like the comets we know. It's throwing off gas and dust. It has a visible tail. That alone is big news, because it means we can study the chemistry of a body that formed around another star, using the same tools we use for local comets. In July and August, observatories around the world piled on with follow-up images and early spectra. By late September, the geometry lined up for something rare, a clean line of sight from Mars as Atlas moved across the background sky. The timing was tight, just a day or two when the angles worked in our favor. Perseverance's camera grabbed frames during that window. One of them shows that bright diagonal line. If you've ever tried to photograph a satellite with a tripod and a few seconds of exposure, you've seen this effect. A moving point of light paints a straight stroke on the sensor. The length of the stroke depends on two things: how fast the object appears to move across the sky and how long the shutter stays open. This is why the cigar shape in the Mars image doesn't mean a cigar-shaped object. It means the camera integrated a point source as it moved. The line's angle tells you the direction across the frame. The line's length tells you the product of apparent sky speed and exposure time. With accurate timestamps and camera settings, you can turn that line into numbers. So what's unexpected here? Not a spaceship, and not a brand new physics clue, at least not yet. The surprise is that the Mars vantage point turns a social media mystery into a scientific opportunity. With two cameras on two planets, Earth and Mars, watching the same object, we can tighten the orbit faster and better than from Earth alone. Think of triangulating a plane using two radar stations. The bigger the baseline between those stations, the more precise the fix. Earth and Mars were separated by tens of millions of kilometers during the pass. Even one reliable streak from Mars, matched to Earth-based tracking, can shave uncertainty off the orbit and help tell us how big and active the nucleus might be. There's also a practical reason this matters now. As Atlas approaches the Sun, the view from Earth gets worse for a while. The comet sits closer to the Sun in our sky, so glare becomes a problem. It's like trying to spot a firefly near a street lamp. Data from Mars during this glare window keeps the orbit solutions fresh and reduces the chance we misread subtle effects later on. Those subtle effects are worth watching. When comets heat up, they release gas and dust. That outgassing acts like a weak thruster. If the push is strong enough, it shows up as a small departure from the path predicted by gravity alone. Oumuamua triggered a famous debate because a tiny non-gravitational push showed up in the data while the object stayed strangely cometless. Atlas doesn't look like that. Early fits don't require a big extra push. That's consistent with a normal, actively outgassing comet, whose forces mostly cancel out, or average small over time. As the Sun heats it near the end of October, that could change. If later measurements show a measurable drift, it will likely be the familiar story of sunlight, sublimating ices, and a bit of gas acting like micro-rockets across the surface. Still, we should be honest about other explanations for that Mars streak. Cameras in space deal with cosmic rays all the time. A charged particle can hit the detector and leave a sharp, bright line or a little burst of pixels. Processing artifacts happen too. The difference is in the details. Cosmic ray lines tend to be razor-sharp, sometimes segmented, and don't care about the expected direction of a moving object. Motion streaks tend to match the predicted track, and often carry the same blur profile you'd expect from a point of light moving during an exposure. If more frames exist from the same session, and if their streaks match the predicted position, angle, and length for the known exposure times, The case for "that's the comet" gets strong fast. What about the truly exotic claims? To move beyond hand-waving, you would need multiple frames from different instruments that all point to a shape, a repeated behavior, or a flight pattern that can't be explained by natural motion and outgassing. Right now, we don't have that. What we do have is a comet on a hyperbolic path that looks and behaves like a comet. As more data arrives from space telescopes and Mars orbiters, the burden of proof for extraordinary ideas only goes up. Comparing Atlas with our previous interstellar visitors helps set expectations. Oumuamua looked dry and odd. Borisov looked like a textbook comet. Atlas so far lives closer to Borisov. Gas, dust, a tail, and nothing that demands a new category. That's quietly profound. It suggests interstellar space sends us not just one-off shards or fluff, but solid icy bodies big enough to survive the trip and light up when warmed. Each addition to this tiny sample of 3 narrows our models of how other planetary systems form and fling debris into the void. So what happens next? Space telescopes like Hubble and JWST can pick out signature lines in the comet's light. Molecules like CN, CO2, and water leave fingerprints that tell us about the ices in the nucleus and how they change as heating ramps up. Color measurements of the dust can hint at particle sizes and composition. If Mars orbiters captured anything beyond the rover frames, images, spectra, or even upper limits, that information still matters. A non-detection sets a ceiling on how bright or active the comet looked from that angle at that moment. Put together, these pieces help build a daily log of the comet's behavior as it rounds the sun. For people hoping to see it themselves, set expectations low and patience high. Atlas is not a backyard showpiece. It's faint. Binoculars at a dark site or, more realistically, a small telescope target. The viewing should improve after it slides past the sun from our point of view, when the glare dies down. Finder charts from ephemeris tools will be your friend. If you have a camera with manual controls, even short-tracked exposures can reveal a thin tail or a small coma as a fuzz against the stars. If you're the kind of viewer who likes to pitch in, there are simple ways to help. Pull the current coordinates from a trusted ephemeris. Note your location, the time in UTC, the instrument you used, the exposure and filter, and your estimate of brightness. Share your observations with the community groups that compile amateur data. When many people do this across a range of locations and times, small patterns pop out, like minor brightening trends or changes in the tail direction, that professionals can check against larger telescopes. Crowdsourced science shines when the target is faint and the window is short. So, did Mars catch a spaceship? No. It caught something better for science. A clean, second viewpoint on a fast-moving interstellar comet at exactly the right moment. That extra baseline turns a mystery image into a data point, and that data point helps us answer the real questions sooner. How big is the nucleus? What is it made of? And how does it respond to sunlight? Over the next few weeks, watch for 2 things. Any official release that ties the Mars streak to a measured sky position, and any hint of a small non-gravitational drift as the comet heats up near the end of October. Either one will sharpen the picture we're building. If you're here for wonder with receipts, stick around. We'll keep chasing 3-eye Atlas with clear eyes and open methods. No hype necessary. And if you do get a photo or a faint visual, share it. The sky is huge, the window is short, and the more angles we have, the smarter we get. Thanks for watching. Tonight, keep an eye on the sky. Observed, we'll post updated charts and viewing windows below. Plausible. If the pattern holds, the next change should show up soon. Speculative. If it doesn't, we may be seeing control, not coincidence. If you capture anything, time, location, and gear, drop your log in the comments. We'll feature standout data next episode. For more videos, hit subscribe and tap the bell. Stay curious, stay kind, and keep looking up.